Okay, the other day we learned about rules called the product rule and the quotient rule. So today it's time to learn about another exponent rule called power to a power. So the example in front of you has a base of 3. And when you look, the 3 has a power of 7. But you also have this whole expression raised to another power. So that's why we call this power to a power. What this means is we have two groups of the 3 to the 7th power, just like I've shown you right here on the note sheet. So if you have 3 to the 7th power times another 3 to the 7th power, what we could do is show the entire expansion. 1, 2, 3, 4, 5, 6, 7. This would represent the first set of 3 to the 7s. So that's 1, 2, 3, 4, 5, 6, 7. That's right there. Okay, but after that, remember, we needed to show the other expansion for 3 to the 7th. So I'll underline that in blue. 1, 2, 3, 4, 5, 6, 7. Okay, obviously this takes up a ton of space. It takes up a ton of time to write the expansion out every single time. So of course, we want a shortcut rule to figure out how to work with these power to a power problems. So guys, if you see how you have 7 sitting next to the other 7, that's a total of 14, you're right. We have the base 3 to the 14th power, which is exactly what this stands for. So your shortcut is to go ahead and multiply your power to a power. And this is the only time this will work. It won't work when we had plain multiplication or division problems like we talked about the other day. It's only going to work when you have this scenario of a power to a power. So we have one quick example down below here, and this is where I was going to ask you if you saw the shortcut. So again, we'll do this example. We have 4 squared, and the entire thing is going to be raised to the 3 exponent. So that means I need 3 of these, like this down here. I think it's kind of in gray. So that does mean 4 squared times another one times another one. So again, it's kind of like having 3 groups of this thing. And then if we wanted to, we could expand this one out. This one would incorporate 2 of them. And then the center one would be 2 more of them. And the last one would be 2 more of them. So after doing all that work, you realize it's just a long list expanded. Your base is 4, and there are 6 of them. So you could say this is 4 to the 6. Again, that shortcut that we referred to, if you wanted to in the very beginning and you realized you had a power to a power, you could just multiply. 2 times 3 is 6 altogether. It's because we have 3 groups of 2. And whenever you're doing 3 groups of 2, it's really multiplication that simplifies your work. So, filling in your rule at the top on the other note sheet, when you have an exponent raised to another exponent, in other words, power to a power, you are going to multiply the exponents. Just make sure you keep the base. So from earlier, we had this example where your base was 3 to the 7th power, and then the entire thing was being squared. So yes, we have a power to a power. So you're going to keep the base 3. 7 times 2 is 14. And I think we have the same example here for some reason, so obviously just fill that one in. And then go ahead and pause the video. You need to give yourself a chance to try the remaining examples. When you're done trying them, click play so you can check. Alright, for this one, if you said 4 was your base, and then 6 times negative 3 was negative 18, you were correct. This would be the simplified version of the given problem using power to a power rule. Even if your base is a variable, you're going to keep your variable. 4 times 5 is 20. So you're all set with x to the 20th power. And then down here at the bottom, what they've given us is a much more complicated problem. So you can see how you do have power to a power here. This simplifies to 9, and then 2 times 4 is the 8. And then down at the bottom, I just copied this over so I could work on what I would think about next, because that was the only part of the problem where you do power to a power. I did simplify 9 to the 0 power. Remember, anything to the 0 power is really having a value of 1. So that's why I put this 1 right here that's getting multiplied against this fraction. Now the fraction can be simplified because if you remember your quotient rule, 9 to the 8th divided by 9 thirds, you'll have 3 values of 9 being able to cancel. which means you'll only have 5 left over. So 9 to the 5th times 1 more is 9 to the 5th. If you'd like, we can write that out to show you the whole expansion. But again, it's very cumbersome and it is going to take up a lot of space. When we have math problems with exponents, we want to usually take up the less space as possible. So let's see, I have 4, 5, 6, 7, 8. That represents the top of my fraction, 9 to the 8th power. Then I have 9 to the 3rd power. So that means I'm going to need 3 9s on the bottom. And then to show you the canceling, we could cancel the first pair, the second pair, and the third pair, leaving you with 1, 2, 3, 4, 5. So 9 to the 5th. Still going to be 9 to the 5th, even though we multiplied against 1. So please take your notes, cut down the middle. You're going to tape on page 125 and 126. See me with questions, and if you think you're comfortable, you can do page 3 in your packet now.